as we look at our next example here, we can see two different pieces here that are all sines, all cosines, some being a lot more higher in expression than the other. And looking at this, when I see sine to the sixth, that looks a lot more complex than a sine to the fourth or a cosine cubed. Now right here, a lot of students will want to fall into the trap of saying, okay, sine of fourth to the x minus sine of sixth to the x is going to be a minus sine squared of x, and just leave it at that. However, we can't really do that with exponents. We need to factor out. So I'm going to make my vertical line here, and I'm going to simplify the right-hand side this time. So for my first expression, I'm going to pull out a sine of fourth to the x. And then I'm left with 1 minus sine squared of x. 1 minus sine squared of x, we know, is the cosine squared of x. And now that I've got a whole long row of terms I'm just multiplying, I'm going to combine my common terms, which gives me the expression I was looking for. Sine to the fourth of x times cosine cubed of x. The last example deals with square roots and absolute values. And really the only thing we've got to worry about with this absolute value is that when we take a square root, we don't have a negative underneath the square root. So here with this guy, we've got to make sure that this piece always ends up being positive, and that's really all this absolute value takes care of. So originally I've got 1 plus the sine of x over 1 minus the sine of x. I'm just going to work inside the square root, and the easiest way to do this is going to be taking the conjugate. 1 plus the sine of x. My numerator then, 1 plus the sine of x quantity squared. And in my denominator, I'll have 1 minus the sine squared of x. And this 1 minus sine squared of x in the denominator ends up being negative cosine squared of x. Since I've got a square root, one of my square root rules is I can separate both my numerator and denominator into separate square roots. This piece right here, the square root and the square cancel out, which leaves me with 1 plus the sine of x. And then in my denominator here, the square and the square root cancel out, but then you can see I've got that negative cosine of x. I just have to make sure that that value in there is always positive in order for my square root to work out, which is why we've got that absolute value right there. So 1 plus the sine of x over the absolute value of the cosine of x is verified.